Welcome to this quick recap of my solution for Kaggle's LLM Prompt Recovery challenge. So let's do a quick intro to the competition. Typically, one use of LLMs is to rewrite text. So you have some original text, you write some prompt, you give this to the LLM model, and in return you get the rewritten text. This is a typical use of ChatGPT. But in these competitions, we are tasked with an opposite task. So we are given the original text, we are given the rewritten text, and we have to guess the prompt that was given to rewrite the original text. Okay? So the input is the original and the rewritten text, and the output is the prompt that was used to transform the text. What is the evaluation metric? So it's very simple. We take the prompt, the real prompt and the predicted prompt. We compute text embeddings using T5 models, and with those embeddings we compute the sharpened cosine similarity. And what is the data for the challenge? So there is no data. The challenge defines the task that we have to do, but the data is not available. So the test set is hidden, and we have to submit code with the solution. The solution is executed on a server, but we never see the data. We only see the results of the evaluation. Some stats about the competition: the prizes were very good, up to $200,000. A lot of participants, close to 3,000, 2,000 teams, and many submissions were done to this challenge. Okay, so what was my journey in the challenge? So this table summarizes the most relevant submissions done to the challenge. So on a first step, I tried using Mixtral, one of the most powerful publicly available LLMs, and a naive submission with that model only scores 0.53. Okay, and very surprisingly, submitting the sentence that says improve the text to this scores 0.6. So a simple sentence scores better than an intelligent large language model, which is very surprising, one of the most surprising things in this competition. Okay, but if we take Mixtral and use few-shot prompting, which is simply to show some examples of the task and then asking Mixtral to guess the prompt, we can improve the score a lot to 0.61. And if we fine-tune Mixtral on synthetic generated data, we can improve even further. But another magic sentence, we can say, was publicly shared in the forum, and that scores 0.63. So again, a simple sentence is able to beat a fine-tuned large language model. But we can do more things with the models. So if we take 4 different models, we make predictions with all 4 and concatenate the predictions, we can improve the leaderboard score up to 0.64. And finally, if we concatenate this ensemble with the previous sentence, the score rises up to 0.66, which was my best submission. My explanation for these weird things about single sentences working so well is that there is ambiguity in the task. Multiple prompts can lead to the same output. For example, rewrite the sentence using a different word choice can produce the same output that replace beautiful by cute. So it depends on the style of the prompts. The prompts could be very generic, or they could be specific and mention details of the original text. In my opinion, prompt similarity might have been a poor choice as a metric for this challenge, and I believe it is likely that perplexity could have been a better metric for the challenge. So let's go to the things that work for me in the challenge. So as I have already told, an ensemble. It's very typical to use ensembles on Kaggle competitions, but this ensemble was slightly different because the predictions were concatenated. Typically, in classification problems, for example, you average the prediction of the models, but here we are dealing with text, so we simply concatenated the prediction of the models. And I use 4 different models to have a diverse ensemble. So I use Mistral 7b, Yamath 13b, Mistral 22b, that was released a few days before the ending of the competition, and Mistral 8x7b, which is the largest one. And I fine-tune all these 4 models in my own generated data. Another thing that worked was future prompting, but it was much slower than the fine-tuned models, because when you do future prompting, you have to give in the order of 10 examples in the input prompt to the model, and that makes the inference slower than the fine-tuned models, because the fine-tuned models only receive the test sample as input. So it is likely that if using future prompting, it might have been possible to use 1 or 2 models maximum, not 4 models like I did when fine-tuning them. But in this challenge, there were many more things that didn't work. One big problem was the lack of validation data. We didn't have any data for the challenge, so I tried using some data shared by other participants in the challenge, but the correlation between those the scores that I get in those public data sets were not good with the leaderboard. So I ended up using just the leaderboard. So that was a very big problem for doing quick optimization for the challenge. Another very surprising finding in this challenge was that using bigger models did not produce better leaderboard scores, and this was very surprising because in all the literature, when you use a bigger model, you get better results on the benchmarks. So this was very surprising. Using Mistral 7b got the same scores as using Mixtral, which has 8 times more parameters. So I don't have an explanation for that. Probably it is related to the ambiguity of the task, but I'm not sure about that. And I also tried many things to improve my training data, but none of them worked. I also tried scaling the data, since I use GPT-4 for generating the data. It was really easy to scale the data. It was just a matter of doing more calls to the API, but again, it didn't work. So this was one of the most disappointing things of this challenge, that many things that my intuition said were going to help didn't work at all. So that was the story of the challenge. Almost anything that I tried didn't work. So what did I learn in the challenge? It was my first hands-on experience with LLMs, so I learned to use them, to fine-tune them. I also learned that it was possible to quantize the models to float for precision, and that allows to use consumer level hardware. So I was able to run Mixtral on my computer, and I also learned that it was possible to do adversarial attacks against the attention embedding model, because the winning solutions was Lucraria. So what is this? So most of the top performing teams did some kind of adversarial attack against the T5 sentence embedding model, and they were able to reach some sentence like the one on the screen that score much higher than the public prompts like improve the text to this. So this was very surprising, and if we go to the leaderboard, we can see that some teams are scoring very high, 0.71, while my solution, which did not use that kind of adversarial attack tricks, was only able to reach up to 0.67 on the private test set. So this was all the recap of my solution. You can go to Kaggle to see more about the competition. Also, all the code I prepared for the competition is open source, is publicly available on GitHub. I will post the links in the description of the video, and the GitHub repo has a website with all the work and the process that I did for the challenge, like understanding the challenge, all the iterations that I did trying to optimize the model, a deeper solution summary. So all these resources could be helpful to you to dig more into the challenge, and thank you for watching. See you on the next video.